Yeah, hello everybody. My name is Kai Weist. I'm implemented as a PhD student at the Department of Construction Management of the Technical University at Dortmund in Germany. I'm very happy to present today our approach for multi-criteria decision support in the construction management, and therefore we take a look and consider the whole life cycle of a building to investigate the economic efficiency of a building element or as well the whole building. I wrote the paper with Lisa Lenz, Jan Winkels, Julian Graefenstein, and Mike Gralla, which are also applied to the Technical University of Dortmund at the Construction Management Department. First of all, a short agenda. What do I want to show to you today? First of all, I will give a short introduction to decision making in construction management, CM. Then I will show you how software synthesis methods and building information modeling can be used for multi-criteria problems or decision making with multi-criteria problems. Then I will show our approach for digital variant comparison in the construction management. And at the end, I will give a short conclusion and an outlook about our paper. So when we think about decision making, everybody knows, or all of us, I think, know they are permanently carried out in the construction management and as well in construction management projects. Decisions which are done are often affected by different parameters. So we do not have the one parameter which is influencing a decision. We have many parameters which are have to be taken into account to make a decision. And furthermore, these different parameters often have a relationship to each other or working against each other. So when I have a parameter 1, which will affect a decision, and I change this parameter, then this will also have an effect or will also influence other parameters in different ways, of course. Then we have different participants. When we are in a project, we have different project participants, which mainly or very often have, of course, different goals. Also, when we consider, and we have to consider the life cycle of a building, then again, we will have different goals and different parameter values or different parameters. So, for example, if I make a decision based on the design phase, it doesn't mean that the best solution which is made in the design phase is the best solution, for example, for the execution or for the operation phase. And also we have the possibility of changes in the design or also in the execution phase, which can be done by the client. So other than in the automotive industry, where I can order a car, I can change different parameters. But when I have done the order, when the order process is done, I'm not able to change anything. And this does not apply in the construction management. By that, we have a highly increasing complexity and multi-criteria decisions in the construction management. And we thought about how can we deal with it? How can we make the high complexity manageable? And we are in the position to say, okay, we are using building information modeling to get a source of information. So to put information in our BIM models, which we can use for our decision process. The building information models then will be transparent and centralized. That means that every participant is able to see the same things which all other participants are seeing. And the most important thing, or also an important thing, is that we can take the parameters which are important for the decision making, the input parameters, for example, and can take them into account in the BIM model. So we have the information we need for a decision, and we put them in the building information models. The next step, software synthesis, how they can be used. We see on the left-hand side, we see a manual process of a decision making, and on the right-hand side, we see how it is done by software synthesis in an automated way. So the parameters we have to take into account, the input parameters are the same, but the development looks kind of different. When we take a look on the left-hand side, we have different input parameters, and then we have to merge different parameters and take a look or manually do a constellation of different parameters, and by that we will get some solutions, also in a manually way, which is of course very time consuming and not that efficient as it maybe should be. When we have different solutions, then we have to take a final evaluation and do a final decision, okay, which solution is maybe the best, for example, for the design phase or the execution phase, or which solution is the best overall. So when we take all phases into account. On the right-hand side, like I said, the approach with software synthesis methods, it's nearly the same, but in the development phase or in the development, everything is done automatically. So the software synthesis method takes all the input parameters we see above, which are implemented in the BIM model, takes it and gets many constellations. So every possible constellation of different linking of the parameters and information will be done automatically by the software synthesis in a very fast way. And by that, we get many different solutions. And the next step is that the software synthesis method is able to filter out solutions which are not possible by different constraints. So we give different constraints, and by that it will filter out, okay, which solution or which solutions are not able to work, we cannot use. Then we get the different working solutions, and then the next step would be that the human has to take one solution or have to decide which solution is the best for the use case. Use case, like I said, we have a life cycle oriented investigation of the economic efficiency of a heating system in this case. On the left-hand side, we see some input parameters which will affect a decision, for example, which heating system will be used or how will I use the heating system, where will it be implemented in the building, and so on, how will it be implemented. By that, we have a multi-dimensional influence factors. We have a high complexity decision-making situation. And how do we deal with it when we use software synthesis? We are taking the input parameters and compile them in different modules. And on the left-hand side, we see category numbers, for example, from 1 to 13. And every category is created as a module in our software synthesis process. And when we have the decision process, the decision process at the end will create output modules. So again, modules which contain different information about criteria, which then can be used. I will show it in our modular decision-making workflow, MDMW. At the bottom, we see the input parameters, then in green, observation, analysis, and planning phase. This is done automatically, so by the software synthesis process, software synthesis method, and then we get an output. This is also done in an automated way. I will explain it. The input data, like I said, we have modules which is the same as the categories, and we have different parameters in it. Different information we have to consider when we want to make a decision. These are all input data we need, and then the software synthesis method will compile them. So it is linking every possible constellation of modules and of possible constellations of parameters. And then, like I said before, by constraints, it will filter out, okay, which solutions are not possible or does not meet the required standards we want to have. Then it will get out different output modules, which are then ready for, or which is then the pre-decision. So the module O1, you see it on the right-hand side. There we have different costs, for example, so different criteria which are important to make a decision. So labor costs, material costs, and so on. This is at this moment for the construction phase. So module O1 is construction phase. Module O2 then, for example, could be the operation phase. We have the design phase and so on. So we will have different modules to take a decision. And what is the outcome? The outcome of this process, for example, could be like this. This is one outcome. So one outcome which shows what input parameters are influencing our criteria in what way, in what kind of way. So left the construction phase, we have the operational phase, the revitalization phase. Then we have different boundaries. We have an upper boundary, a lower boundary, and these are the constraints. So this means when I have a solution and a criteria which is not between the different boundaries, it will be filtered out because it's an unusual constellation of solutions. Then we have the different parameters or criteria in this way: labor costs, material costs, equipment costs. Then we have other criteria which are important for the construction phase or the operational phase. So, for example, dismantling time or connection to the public grid. And we see regarding the different operational phases, we have different information or different values of the criteria. And by that, we are able to get a solution which is maybe the best for one phase, or we can take an overall look and decide as a human which is the best solution. Like I said, the software synthesis approach will only make a pre-decision, and the final decision has at the moment to be made by human. Conclusion and outlook, in my opinion, very simple. We showed that different input information, input parameters are able to be stored in BIM models. I think this is not a new aspect at the moment. We can use the BIM models, of course, as a transparent and centralized database. We can use software synthesis methods to generate different variants of out of the database. So the database is in this case our BIM models. We can give boundaries or constraints, and by that the software synthesis method can filter out unusable variants. Important to know is the final decision has to be made by human. Overall, we can shorten up the planning, decision, and implementation times, and by that the decision making will be getting much more efficient. Next objectives or goals which could be addressed are to use AI-based methods and information technology to merge it with the strength of human decision making. Also, AI could be used to get the decision making more efficient. That's from my side, everything. Now I'm ready for questions or comments. Thank you very much.